remember how much trouble vector subtraction was going to have? No? Oh, maybe I did a really good job at this. Because it's always caused a little trouble. I'll make it even easier for you. This won't take long today. First, let's talk about what is vector subtraction, right? Now, this kind of leads into tomorrow's, and I'm starting to wonder if I should maybe change the order of the days. He realizes as he gets started, so maybe next year I'll do that. But anyways, when you're dealing with sort of word problems, the resultant, if you're talking about plane and wind, P and W, right? So you know that the resultant is equal to the plane plus the wind. And technically, there should be little vector symbols over top here, right? So the plane velocity vector plus the wind velocity vector results in the resultant velocity vector. And the plus sign in vector addition indicates that we should place them tip to tail, right? So here we have a picture of that. We have the plane, tip to tail with the wind, and there's our result. Everyone should be good with that. And I went through this last year as well, and read that. So if we rearrange to solve for the plane or the wind, if you need to find the plane velocity or the wind velocity, we would rearrange R equals P plus W, and you would get P is equal to R minus W, all vectors, or wind is equal to R minus P. And you might remember doing the vector golf assignment with the ball in the wind and stuff like that, right? Okay? So the plane speed is the resultant speed minus the wind speed. The wind speed is the, and I say speed, but I mean velocity. The wind velocity is the resultant velocity minus the plane velocity, right? So now we're not talking addition anymore, we're talking subtraction. Right? So this will mean vector subtraction when you're trying to find the wind or the plane speed or the boat or the current or one of the elements or the components, if you will, of the situation. When you're trying to find one of them and not the resultant, well, then we're looking at vector subtraction. Now, vector subtraction with components is incredibly super easy. Remember how last year we had to flip things around and there was like, oh, right? Confusing. How are we going to do it here? To subtract vectors by components, what do? You simply subtract instead of add. Can you do that? You should be able to. You subtract them. Oddly enough, people still get it wrong because they forget to. It's not the subtraction part they find hard, it's the knowing to subtract they find hard, right? So suppose you have a situation like this, where we need to take vector C is equal to vector A minus vector B, and there are your values for A and B. So here's an example. Let me just see if it's on the next page. Yeah, it is. Okay, good. Okay, so I'll just pause there. Okay, so these are just made up vectors. They mean nothing, right? We need to take vector A and subtract vector B. So let's follow our steps from yesterday. There's A and B again. You've already got them, right? I just put them on this screen so I could refer to them. That's all, right? So I'm going to first draw my pictures. So there's vector A, east 26 south. So east and south, right? I had a few people asking that yesterday. How do you know kind of how to draw it? You draw east, and then you draw south in that order, right? East, south, 26 degrees, 12. And B is east and north. So east and north, 14 degrees. 8 is our unit. We don't even know what the unit is. Doesn't matter. And we've got our X and our Y here. Okay, so next step is to find the values of A and X, right? I like to do X first, just whatever, no reason. X is beside the angle, so we're going to be the adjacent side, so we're going to use cosine. AX equals 12 cos 26. It's to the right, so that's going to be positive. Oh, I haven't got them figured out. That's not very good. 10.79, 10.8, I guess. Good enough. Positive, so to the right. 12 sine 0.6. 5.3. So that's the stuff we did yesterday, right? Finding components. We're going to do the same thing with b. Again, bx is the cos. Is the x always going to be the cos? Not always, right? It's only that because the first one is east. If it was north and if it was like this, right, then that would be the x component. So it could be sine. So don't always assume x is cos. So the bx is going to be 8 cos 14. And the y is opposite. That's sine. That's going to be 8 sine 14. Hope I'm in degrees. 7.8. You want to make sure you're in degrees. I have the x is to the right and the y is up as well. So they're both. Oh, hang on. This y should be what? No, that y should be negative. Nobody mentioned that. 8 sine 14. 1.9. Okay, so same steps as yesterday. Find the x and y components. And then the step yesterday was to add the components. But because this is a vector subtraction question, what are we going to do? We're going to subtract them. That is literally it. So cx, right? Our answer, vector c, cx is going to be ax minus bx. So that's going to be 10.8 minus 7.8. And cy is going to be equal to ay minus by minus 5.3 minus 1.9. And I don't have those. Well, that's just it. I can do that one in my head. This one here is going to be minus 5.3 subtract 1.9, which I think is 7.3 minus 7.2. Okay, so those are our x and y components of our resultant, our c value. Now what? Redraw the picture. Oh, and I don't have it. Redraw the picture. So cx is going to be 3, positive 3, so to the right. The y is minus 7.2, so 3.0 minus 7.2. Not r, let's call it c, because that's what it is. So c squared is going to be 3 squared plus 7.2 squared, which should be negative, but it's not going to matter. And you get squared. 7.8. And we don't even know the units. Just a number for now. 7.8. And of course you need the angle. It's always where you start. Again, you can't always assume that it's going to be sort of one over the other, right? So here it's opposite over adjacent. It's always going to be that. Opposite over adjacent. Here the opposite is the 7.2. It's the y, I guess. 7.2 over 3.0. Now, should the 7.2 be negative here? Or is that going to cause problems? Say that again, Tanner? You're right. You shouldn't put the negative in there. In fact, it's going to mess things up, right? Because now we're just talking about a geometric triangle, right? We know that it's down, so don't put the negative in there. It's going to mess up your calculations. 7.2 divided by 3.0. 2.4, second function tan. 67 degrees. So that would be east 67, south, I think, right? So what's different about vector subtraction? That one little step. That's it. It's a good review from yesterday. One little step, just subtract. Now, having said that, tomorrow when we start getting into the word problems, it's that recognizing it has to be subtract, right? That's usually the problem. So we'll work on that tomorrow. So I'm going to give you some time to practice here. If you need practice time on kinematics, I'm still waiting on some pre-tests from some people. I'll shame them again by yelling out names. But you got this period. I'm going to do the word problem stuff tomorrow. Band guys aren't leaving until after this class, right?
We're not leaving until 11:30.
Okay. And then Friday will be a work period as well. Yes, thank you, Sean.